Alright, so this session is for virtual private cloud GCP. So our objectives of this course is explore the default VPC network, create an auto mode network with firewall rules, convert an auto mode network to a custom mode network, create custom mode VPC networks with firewall rules, create VM instances using Compute Engine, explore the connectivity for VM instances across VPC networks. Right. So let's explore it. First task is to view the subnets. The default network is subnet in each GCP region. Click VPC network. So we go to VPC network and click VPC networks. Or the default network with its subnet. So every region has its own subnet and its IP address ranges. Okay. Like Asia Northeast, this Northeast one has this. This is the subnet ranges. It has a gateway. Each of them has a gateway. Alright. So routes tell VM instance in the VPC network how to send traffic from an instance to a destination, either inside the network or outside GCP. Each VPC network comes with some default routes to route traffic among its subnets and send traffic from eligible instances to the internet. In the left pane, click routes. So now you can notice that if you notice there is a route for each subnet. Alright, so there are 21 routes for now, and if you click on any one route, and one for the default internet gateway. So in the left pane, so now we can see that there is a route for each subnet. And one for the default internet gateway. Okay. These routes are managed for you, but you can create custom static routes, direct some packets to specific destinations. For example, you can create a route that sends all outbound traffic to an instance configured as a NAT gateway. With the firewall rules, each VPC network implements a distributed virtual firewall that you can configure. Firewall rules allow you to control which packets are allowed to travel to which destination. Each VPC network has two implied firewall rules that block all incoming connections and allow all outgoing connections. In the left pane, click firewall rules. Notice that there are 4 ingress firewall rules for the default network. Default allow ICMP. Allow. So it is allowing me all the connections. for ingress. These are rules allow ICMP, RDP and such ingress traffic. So basically it's 22 port, 389, TCP and UDP. These are ranges and ICMP. The targets, filters, protocol ports and action columns explain these rules. Filters, okay. Protocols, which protocols are allowed. Action, allow. Allows internal IP address. These are the external IP addresses. Okay. The target filter protocols. Correct. Read the firewall rules. In the left pane, click firewall rules. Set all default network firewall rules. Click delete. And then delete. Now we'll go ahead and delete the default network. So we'll go on VPC networks. Alright, all seems to be deleted. So now we'll go to VPC networks, select default, click delete VPC network. Okay, deleting it. So once it's done, we will just check on the routes, if there are any routes available now. Okay, that seems correct. So let's go to routes. There are no routes right now. Firewall rules, there are no rules. Okay, so we don't have anything right now. Now let's try to create a VM instance. So it should not allow us to create. Let's go to the compute engine, VM instances. Let's try and create it. Just select default values, create. Okay. It shows that there is an error, right? Because there is nothing in the networks. There is no network available to connect to. No network available. Let's cancel this. Now let's create an auto mode network. Suppose you have been tasked to create an auto node network with Two VM instances. Auto mode networks are easy to set up and use because they automatically create subnets in each region. However, you don't have control. you don't have complete control over the subnets created in your VPC network, including regions and IP address ranges used. Feel free to explore more considerations for choosing an auto mode network, but for now, assume that you are using the auto mode networks for prototyping. Let's create an auto mode network, VPC network with firewalls. So let's go back to VPC network. Click VPC networks. Let's create VPC network. For name type my network. Okay. For subnet creation mode, click automatic. Auto mode networks create subnets in each region automatically. It's creating subnets in each region automatically. For firewall rules, select all available firewall rules. Okay. These are the same standard firewall rules that the default network had. The deny all ingress and allow ingress rules also there, but you cannot select or disable them because they are implied. These two rules have a low priority, so that the allow ICMP internal RDP SSH rules are considered first. Okay. Six 5535, just lower priority. So higher integers indicate lower priority, so that ICMP internal IP rules are considered first. Okay. Now we can go and click create. When a new network is ready, notice that a subnet was created for each region. Okay, so once it's done, you'll be able to see that. We got the IP address range for the subnets in this and this. These will be referred in the next steps. Okay, let's see. Awesome. So we've got this. Now I will just copy the US center one IP address range. Okay. Now let's go ahead and try to create a VM instance in the US center one. So we go to Compute Engine, VM instances, Compute Engine, create. So the property name should be mynet US VM. Okay, region US Central 1. Zone should be C. It's correct. Machine type F1 micro. Okay. The rest of things will remain as same. Networking, we can see selecting the range of the US Center 1 subnet. Okay, let's click create. Alright, so we can see we have mynet-us VM created. Verify that the internal IP address for the same is 02. Okay, and now we should be 02 because the one is reserved for the gateway, and you have not configured any instance in that subnet. Okay, now create a new instance in the Europe West 1 region. We'll go ahead and create an instance. Once again, this time we'll give it the name my net EU VM. This time we select Europe West 1 region. The zone should be Europe West 1-C. Okay. Europe West 1 falls in Belgium, and we again select the F1 micro server. Okay. And we click create. Okay. Verify the internal IP address for an instance was assigned from the IP address range of the subnet in the Europe West 1. So we hold on for the internal IP to come up for this new VM. Yeah, it is from 132 subnet. Okay. The external IP address for both the VM instances are ephemeral. If an instance is stopped and ephemeral, external IP address assigned to the instance are released back into the general compute engine pool and become available for use by other projects. When a stopped instance is started again, a new ephemeral IP address is assigned to the instance. Alternatively, you can reserve a static IP address which assigns the address to your project indefinitely until you explicitly release it. Okay. Let's verify connectivity to the VM instance. The firewall rules that you created with my network allow ingress SSH and ICMP traffic from within my network. So the firewall rules that you created with my network allows ingress SSH and ICMP traffic from within my network internal IP and outside that network. On the navigation menu, compute engine VM instances, VM, note the external and internal interface from mynet VM. This okay. For mynet, using click SSH to launch a terminal and connect. Mynet USVM. Let's click on SSH. So we're trying to connect to the US VM. You can SSH because of the allow SSH firewall rule, which allows incoming traffic from anywhere. TCP/22 SSH connection works seamlessly because compute engine generates an SSH key for you. By default, compute engine adds the generated key to project or instance metadata. Your account is configured to use OS login. Compute engine stores the generated key with your user account. Alternatively, you can control access to Linux instances by creating SSH keys and adding public SSH keys metadata. Okay, test connectivity to Mainnet EUVM's internal IP. Run the following commands, replacing Mainnet EUVM's internal IP address. So we just wait for the SSH connection, and we have the IP for the internal IP for the EU server. So we'll try to ping that. Send 3 packets. Okay. Okay. Then ping my internal IP because it allows internal firewall rule. Repeat the same test by running the following. Now we will try to connect ping via the hostname. You can ping Mainnet by its name because VPC networks have an internal DNS service that allows you to address instances by their DNS names instead of their internal address. This is very useful because the internal IP addresses can change when you delete and recreate instances. To test connectivity to Mainnet EM's external IP, run the following command now, replacing this external IP. So we'll try and connect ping the external IP of the same server, store it, we'll just utilize that, and see if we're able to ping it. Yep, we are able to ping it. You can SSH to Mainnet USVM and ping Mainnet internal and external IP addresses as expected. Alternatively, you can SSH to Mainnet EUVM and ping Mainnet USVM's internal and external IP addresses, which also works. Okay. Now we'll try to convert the network to a custom mode network. The auto mode network worked great so far, but you have been asked to convert it to a custom mode network so that new subnets aren't automatically created as new regions become available. This could result in overlap with IP addresses used by manually created subnets or static routes, or could interfere with your overall network planning. So just come out of this window. Let's close it. Okay. For now, let's go back to the VPC network. VPC networks. Click My Network. Okay. Now you click on Edit. Select Custom. For subnet creation mode, click Save. Return to the VPC network page. Wait for the mode of my network. Custom now. Okay, it has changed to custom now. You can see this. Now you can click refresh while you wait. Yeah, it's custom now. Okay. Converting an auto mode network to a custom mode network is an easy task and provides you with more flexibility. We recommend that you use custom mode networks in production. Okay. Alright, so I'm stopping it over here and I will resume in the next session for the same tasks from here.